Hey everyone, this is Melissa Canizon, and I am going to do my presentation on the insecure direct object references for the information security seminar. What I'm going to be presenting on today is from OWASP's top 10 list. And if you haven't already, you can go ahead and navigate to the slideshow presentation. This is where you would have landed, and if you followed the directions on it, it shows you how to navigate to the real site where my presentation is, the real URL. So I'll go ahead and follow these directions real quick, show you how it's what we're doing. We're just going to manipulate the URL a little bit to get us where we need to go. So as you can see, I've changed I use the URL to navigate to my profile page that shows all of the slides that I've uploaded. Now I'm going to go ahead and go to the actual site. Ta-da! And that is the actual slideshow presentation for the remainder of this presentation. That's a little redundant. Anyways, insecure direct object references have to do with how we refer to information, how we find objects in a directory or database. This is the formal definition from a OWASP site. A direct object reference occurs when a developer exposes a reference to an internal implementation object, such as a file, directory, or database key. Without access control check or other protection, attackers can manipulate these references to access unauthorized data. There's a lot going on in that definition. So what we're going to do for this presentation is we're going to try and break it down into smaller chunks to understand what they're trying to get across and what the actual security issues are. This is going to be our breakdown of topics for this presentation. We're going to have a couple of definitions, a little vocabulary lesson for you, and then we're going to talk about how people use insecure direct object references, what you can do with them. We're going to talk about what makes them so threatening and how you can prevent this vulnerability on your own sites. So our first one we're going to do is the definition of objects. Objects are what you have to hide. They're going to be everything that's in your directory. Like the definition said, it could be a file, it could be a directory, another directory, it could be a database key, it could be pictures, videos, it could be operations. There's numerous things, all boils down to content that you do not want people to have access to. You need to think about in your web application, what's available and what needs to be secure. Can you share all of the objects that make up your entire web application with the world? Probably not so much. An attacker could easily get into your site and they would be able to get into the configuration files. If they got in the configuration files, they can completely bring down your entire application. So, objects, they're your data, it's your information, it's your files, your images, your videos, they're resources. And like I said, they could be stored in either a processed or an unprocessed format, meaning that it could be a raw data object, such as a picture or somebody's name, or it could be an operation, a piece of code that takes little chunks of data, puts it all together, and brings back a whole bunch of meaningful information to you. So an object really is a thing that's stored and retrieved. Sometimes what we'll do is we'll just say, hey, web app, go get me a picture. But sometimes we say, hey, web app, can you create a table with all the little pieces of data that are floating around in you? Many times, an object is a form of content that's stored and presumably kept safe from people who don't need to access it. So moving on, let's define references. References, this is where your objects are. So we all know what a reference is, and if not, I'm going to ask you, how many papers have you written and how are you getting through college? For the purpose of our definition, we're simply going to say a resource is a source of information. It's how our content, our resources, our objects, how it's all referred to. So a user will make a request, such as for an object or a table, by inputting information into the computer, into the web application. The computer makes a reference based on that input to find and retrieve the data. Sometimes it'll just retrieve the single data file. Sometimes it retrieves multiple data files and, like I said, brings back a table. Could be your bank invoice. It just returns all the information that's all the data that's needed to construct the object. Now, usually a reference will define the path to an object. It's in the name of the object, the location, and other locating information that defines how to retrieve and present an object. In this case, we're looking at how the path name, also the URL, contains the reference based on user input. So a little more clearly now, we'll take a look. Objects are usually referenced in the path name, that is in the URL. So here I have a domain, and our domain is called directory.com. In our domain, we have object files where we could tell the web application, hey, I want to look at object 1. Hey, I want to look at object 2. Hey, I want to look at object 3. So when we input that information to the web application, it's going to bring us back to the specific URL or the path name that's referring to the object we asked for. So now that we understand that our object is referenced by its location in a directory, which happens to be how we form a URL, it's kind of like a map. Now we want to ask, is that object kept secure? Should the access to that object be restricted? Well, we need to find out. If the answer is yes, you want to know, can the user that has not been authenticated access it? Or can a user that has not been authorized access it? Here's more definitions for you. We need to know the difference between authentication and authorization. Authentication verifies who you are, where authorization verifies what you are allowed to do. So when a user is authenticated, they're given certain permissions to access certain objects, either in a directory, a domain, a database, what have you. An authenticated user does not have permission to access all of the objects. And in order to access an object, you must be authorized. Therefore, in order to access any object, you must be authenticated and authorized for that permission. All right, our vocabulary lesson is now over. We're going to be defining what an insecure direct object reference is. This is showing where you hide your objects in plain sight for everyone to see. So usually the user is authenticated. They don't always have to log in to be authenticated. Sometimes being in the web application is saying you're authenticated. The object is accessed by manipulating a direct reference to it. So this occurs when a web application relies on the user's input to retrieve an object. If the web application is told to retrieve an object that should be secure, and it doesn't verify that the user is authorized to actually access that object before it returns it, then you have a data breach that's occurred. Insecure direct object references allow attackers to bypass authorization and access resources directly by modifying a value of a parameter that's used to point to the object. So here is how it works. We have two URLs here accessing two different objects. Hi there, object one. The user wants to see you, but this user is only allowed to see object two. Maybe after the user gets to see object two, the user can get you also. So you notice how the user is referenced and the object is referenced in the URL? By changing the object value in the URL to another value, you're able to retrieve information. Now, does the web application use the input from the user to construct a path name? That's the ultimate question. If so, then you should be able to access files in a forbidden part of the directory by manipulating the path through the user input. So if an authenticated user's input is referenced, then can the user manipulate the input and access info they're not authorized to? Now, like you had done earlier, you had seen where you'd been able to access through the site, through SlideShare, to get to the different PowerPoints that I made. Well, you could do the same thing with any other website. Here, I can simply go to the URL of SPSU and change this little number up here. It doesn't necessarily say what that number means, but let's find out what happens. And it changes to the My Database class. Oh, go figure. Another way of us manipulating the URL just to get around and find out what else is on the website is we could go back in the URL. I mean, here we're at one website. Let's erase all this. You can see that it's the e-hacking website from 2011. It looks like 05. And then this is the actual web page we landed on. So let's delete this web page and see what's in this back directory right here. And it's an archive for May 2011. Well, that makes sense. That's where the 5 comes into play. So if you keep doing that, you can just keep going up and up the directory, go around the entire site. Go to 2011. They may not have a direct landing page for those directories. Oh, look, this one does. Archive for 2011. Sometimes they don't create web pages for every instance of a directory in their domain. We can even go to June and see if June works. Anyways, let's get back on track. That's enough fun of that. So that's pretty cool stuff, but it gets even better. There we go. So we can play with the URL to see files in a domain, and this is something else we can do. We know websites don't show all of their files that are stored at that domain. So maybe if we did a Google for those files that aren't shown, we'll be able to find them. And that's exactly what you can do. Here I'm telling Google just to look in the title for a reference of the index of and a password. I'm also looking for a root directory. If you keep looking, you can do all sorts of different searches. You can search by PDF type or file type, sorry. You can search by multiple things. The last bullet point I have on here is going to search for an index. That's a file transfer protocol. And in the URL, we're looking for CGI-bin, which is the configuration files for that website. So I can give you an example of us doing that too. Let's go to Google and we'll search for all in title, index of root. We'll see what pops up. It's pretty interesting how some people just have their passwords out on files here. This is a great site that I had found earlier. This is Riken. Riken is a Japanese research company. And what they have right here, it looks like, is all archives, or it's a directory. And what we can do is just go back because we're at the root directory, and here we go. This is their landing page for that. And you can see that this is all of different types of software that they may use it to reference. You can go up the directory too and look at all the different things they have. And if you look, I mean, a lot of this stuff looks really old. There's 2001, 2002, but they also have stuff from 2014. Here's some docs. Pretty neat stuff. And on with the show. So another cool one that I'd found, this, like I was telling you, just searching for passwords. I actually found a website that has their passwords saved in a text file. And here are the passwords, and here's the website. Now, these passwords, if you try them, they're no longer any good. These were just the mock passwords from when their website was first up and running. I obviously didn't want to start handing out password information, username and password information on YouTube or through a presentation. But just to give you an idea of what some web applications expose, some of the information they can expose if they're not protected properly. Now, another way you can use direct object references is moving up and down the directory like we did earlier it's kind of like navigating in the command line. And what's really, really interesting about this is this is preventable. Some web applications actually prevent this type of navigation. So alternately, you can just use the web language. You can use %2e for your periods and %2f for your slashes and navigate that way. Now, one that's really cool to do is I think I did it with Peros earlier. So let's go back to Peros. Peros is a tool that's used to enumerate a website. You can it's kind of mapping out all the different pages that a site has. Anyways, this is the web page that's talking about using this security tool. And we're going to practice the ... method. So what we're going to do is put in here /. And it takes us back to the main archive. Here's another one that I found really interesting. We're going to do the ... method here. And it'll take you back to this landing page. Really interesting. You can add more to your dots and your slashes. So we can actually navigate through the directory. Let's say we want to go to an admin file, see if they have an admin file. You can type whatever you think their file directory is going to be. Look, their admin file is actually under WordPress. So they have a WordPress site. That's pretty interesting. So I guess we could just say -- WordPress. And it takes you to the same thing, same landing page. Anyways, pretty cool way to find different file types that you don't necessarily know are available through a web application. So now the question is, are your objects hidden? When your web application brings back information to the user, is the user able to see where the information was pulled from, how it's pulled from through the URL? So we know what insecure direct object reference is, and we kind of know how to use it. Now, how can we tell if our web application is vulnerable? Well, the best way to tell is by accessing the pages and looking for direct references and pages that should require authorization. There's not a lot of tools out there to actually do this. The best thing that you can do is go to your web pages and play around. Go through your code, review your code, verify what is and isn't secure. Do it with different user permissions granted, user permissions taken away. It really helps if you enumerate the site, like I was telling you with Peros, and the other one is OWASP has a tool, the Z attack proxy, and they basically make a directory tree of the web application, letting you know all the different landing pages and stuff. I was going to show how to use those tools, but that's way beyond this presentation, and this presentation has already taken a lot of time. So let's just keep moving on to prevention. How are we going to protect our resources and objects so that way people can't just access them using the URL? Just keep in mind, input is evil. That's the main takeaway from this presentation, is that if a user can input information, you better beware. And if it's on the web, there's a URL, and the URL, you can always input information into there. You don't always need an input box and a button that says go. So the user can manipulate this input, and it can cause the web application to act a certain way or retrieve certain things. So you need to know, you don't ever trust the user and don't ever trust your application. You need to check to see what input is accepted from users with different permissions. You need to check what input is accepted by the application, and ask, should the application throw an unauthorized code? So what you really need to make sure happens inside your web application is check for authorization on every page before objects are returned to the user. Check to make sure the user is authorized to access those objects. Also, minimize the ability to predict object references. such as in the URL. Don't expose the actual name of objects in such places like the URL. And make sure you are verifying your user's authorization each time these sensitive objects are accessed or requested. Input is very evil. It can be malicious, and you should always validate it before you trust it. So data and input, you don't necessarily need an input box to send it. It could be sent through the URL. Therefore, input into the URL can be submitted to the web application. The URL should be validated before it's processed. What if you're able to change your password? What if when you're changing your password, the URL says username equals your username, change password, and then it has the password listed? You might be able to change anybody's username and password. So always check that the user is authenticated. Always check if the user is authorized to access the resource. And always, always, always check if the input from the user is valid and not malicious or unauthorized. Unless you would like to see what little Bobby tables can do, of course. One way of making sure that users aren't able to access references or access objects through the references in the URL is to use session-based indirection or access reference mapping, which kind of provides a lookup index for a resource instead of providing a direct reference. It's an indirect method for referencing a resource, and it makes it much less likely that an attacker can gain access to additional resources that are on the server, but not the resources they're not supposed to be able to access, and they can't attack it, such as, your admin file, your root file, your configuration files. This is just to kind of give you a mental depiction of what reference mapping actually means. It's user input. The web application will take the user input. User is authenticated already, so they're able to speak with the web application or with the directory. The web application is then going to make a reference map. And that map is going to give them an indirect reference for the object that's being retrieved. And then that app is going to send the resource back to the user, and the user receives the resource and its indirect reference. Before the web app takes it and finds the object, the web application should always check that the object that's being asked for, whatever was inputted by the user, is safe to use. It's sanitizing to make sure that that input is not malicious. Our other way of prevention is in the future. It's not available right now. It's called access control. Access control, it's unavailable, and it's just like Justin. I can let you know this, though. Access control is needed to make sure objects cannot be accessed, and that the access to the objects is controlled by controlling who is allowed to access them. I don't want to go into too much detail about this access control because it is coming up in the future presentation, so I don't want to give any spoilers away. But when we get to A7, missing function level access control, we're going to talk about more. And it's just like having the per page authorization and sanitizing the input to make sure that it's acceptable. This information that I have right here is straight from OWASP's website. And then we have one more that has to deal with access control, and that's unvalidated redirects and forwards. That's not necessarily just clicking on a link that's in your web application. It's also has to do with being able to access different files in your domain, just like we did with the admin files, with password files. It's like when you press go or submit after you change the URL. Once you're authenticated, you're usually authorized, unless you keep your web application secure. So just remember that input is evil, and to sanitize it. Now, I have a nifty little quiz. I challenge everybody to go ahead and take this quiz. It's at this web link, michaelpeters.org/quiz or /quiz. It goes through all of the top 10 threats and vulnerabilities. And it's really, he does a great job of breaking everything down. Also, post in the discussion board and check out the resource reviewers. I know they'd appreciate you reading their work that they've done and appreciate comments on it. Tell them thanks for the info, and tell them what an awesome job they did. I look forward to seeing all of the presentations and reading all of the reviews for the rest of the semester. And I hope you guys enjoyed my presentation.